Yeah, hi. And we forgot to change the title because we first added a title without the BTC to the conference program, and we are today allowed to talk together with BTC about the project. So it's about presenting the multi-provider cloud architecture at BTC and how we implement it there at the moment. And so my name is Christian Behrendt. I'm working for the 23 Technologies as well as for the OSISM project, and we try to build cloud platforms to enable companies like BTC to build private clouds. And I have Timon Schnell with me from BTC.
Hello, my name is Timon Schnell. I'm working at the BTC group, and I'm responsible for the role General Service Owner Kubernetes, and I manage the whole shared service Kubernetes platform at our company. In addition, I'm the member of project member of the project which built our private cloud at the moment. And on this slide you can see how we provide, which services we provide to our customers in the cloud context. We want to extend our portfolio to provide a private cloud for our customers and met them where they are at their transformation. Now we are building our private cloud together with Christian, and everything starts last year here at the ALASCA summit. First of all, we talked to B1 and Ralph. And Ralph introduced Christian to us at the ALASCA summit last year. And now...
And what's important, why the BTC decided at all to have a look on their private cloud journey is that they had a contract with the Gov Digital to build a so-called cloud brokerage service there, so that the Gov Digital can buy in cloud resources from hyperscalers like AWS, Azure, and Google, as well as from Ionos, Stackit, and the sovereign AWS region here in Europe. And this is, in the end, the baseline for also establishing the BTC private cloud in the context of this cloud brokerage service, because the BTC is a company of the EWE concern, and they do a lot of stuff also for other customers. And there you have specific use cases that cannot be resolved like with a public offering like with the Ionos. And this was then the idea to build an BTC private cloud that can then be integrated in the cloud broker service so that you have a multi-cloud service in the end. And this is also the starting point here. So BTC visited the ALASCA summit last year here in Dresden, and we met here in the lobby and had some coffee. And then we decided that it's a good idea to getting to know each other better. And it took some time. We had to do some preparation, and we had to do some calls, so that I was finally invited to a first meeting between the BTC Executive Board as well as the BTC IT Services Management. So this is a subsidiary of the BTC that brings IT services in the end on the market. And I traveled to Oldenburg, and I had some coffee there, and went back home. And then we started with the project.
Thank you. First of all, in February and June, we start some paperwork, get some budget to build and to buy all of our hardware. And in July to August, we implement the first hardware, build them into the racks, put the cables in. And here you can see some pictures of our work in August in our data center. And that's at the moment the hardware we use, and we use for the private cloud.
Yeah, and it's important to say that we did it as a team on site in Munich and did all the cabling and so. And so just to really have a good understanding what we really built there. So we have super micro hardware on the top. We decided to use NetApp as a storage backend. We decided to use 40 for the firewall. And some edge core hardware based on 100G and 400G switches with running a Sonic on top for the network fabric. So a whole greenfield approach inside a single rack that is then attached to an existing brownfield. So we had existing core infrastructure, we had existing out-of-band planes. But this way, it was doable for a BTC to source hardware, and that was not yet usable inside the BTC, and made it really easy to show them, you do not have to use Dell or Cisco or stuff like this. You can use it with a different approach, and the same for the network. So you have not to go with Cisco. You can do it with some other approach, and you can build up and leave spine fabric. And so this was the starting point. It took some time to open the new supply chains and to order the hardware. We had to wait a little bit for the 400G switches because there is some AI hype that consumes a lot of network resources. But we built this up. And then we started to implement a cloud pod with the OSISM framework. And so on the top, we have OpenStack, we have an OSISM manager appliance, and then we control the firewall, the storage, the network, the compute fabric with an in-band manager node with an out-of-band metal box that is responsible for the deployment of all of those bare metal components. So this was the first step to build up this greenfield. And what is important for this is that we try to have a zoning right from the beginning to have a good security concept. So we have an isolated network plane, we have isolated storage plane, isolated management plane, isolated compute plane, and multiple of them, so that it's easy to get in touch with the security team and the SOC, and to start right with building the MVP or the POC with ISO certifications and C5 enablement, and so that it's in production grade environment right from the beginning. And this is the zoning we have on top. So we have those planes, and then we have security zones. And we see everything outside as the internet in the end, so it doesn't matter if it's the corporate VPN or some internal network. We just say this is external, so that we have a zero trust approach on the network side. And we then attach internal zones to this security zone concept to be able to divide the security zones in independent zones from the inside. We have external compute zones, we have internal compute zones, we have internal storage that can be used by external compute via a dedicated data leaf and stuff like this. And this makes it then pretty easy to attach to the existing SOC and to the existing NOC and to be able to operate this in the existing processes of the customer. And in the end, so on the left side, we have the same pictures like before, nothing changed there. On the right side, we have a detailed view on the leaf spine fabric. So we have, in this case, one spine layer. We do not have a super spine layer because we do not yet have enough resources for this. And we decided to not isolate the data leaf and the edge leaves from the spine view because it's an MVP at the moment, and we do this on a logical side at the moment via and VRF on top of the spine layer. So this can be changed in the future. So we just ordered some more hardware to have some more integration there, and to also play around with multiple spines and how can this be combined to have a better isolation on the data fabric, for example, or to have better isolation from the out-of-band plane. So this is things we are currently playing around with. And in the end, you just saw one of those cloud pods that runs in some data center in Munich, and we built multiple of them inside the same data center and also in some other data centers. And then The next step is to build this multi-cloud layer on top, because we think it's nice to have one cloud pod or 10 of them or 20, I don't know. But we think in the end, we have to bring this together with the cloud brokerage service that the BTC already has. Because there are customers that want to use a private cloud, there are others that want to use AWS, there are others that want to use Ionos or StackIt or Blue Surfer or Horizon, I don't care in the end. We want to build on top of this a layer based on the Gardener and with some vertical services that enables customers to bring their own identities, to bring their own securities, to bring their own audit logs and stuff like this. And this is based on Gardener. And here in Alaska, we have Jake, the lifecycle management tool for Gardener that we sponsored around, I don't know, 2 years ago, maybe. And this helps to operate, manage Kubernetes as a service with Gardener on top of those private cloud pods, as well as on hyperscalers, as well as upcoming large clouds here in Europe. And this is our abstraction layer in the end for cloud infrastructure. So we have Kubernetes as the bottom layer for service landscapes that we deploy on top, and then they are integrated with customers. And this is our deepest layer in the infrastructure. And the Gardener is part of the NeoNephos Foundation and sub-foundation of the Linux Foundation Europe. This also includes some more projects like the Garden Linux to have an Linux as a base layer, or the Iron Core to do bare metal deployment, or to the Cobalt Core to deploy OpenStack on top of the Iron Core. And this is the foundation just started at the beginning of this year and is now growing and is sourcing all of those SAP projects, and they sponsored all of them in the Linux Foundation. And the cool thing about this is that this enables us to work together with SAP, StackIt, and T-Systems as small companies like Siberus, which is also here, or Excellent, or 23 Technologies, or Kleiso. And we are there as innovation driver, and SAP and StackIt and T-Systems are there as they give us money, and they adopt the solution on a large scale and show us what they expect that their solution can be used by them. Because an SAP has a different mindset. They work a lot with teams. There are teams for virtualization and teams for network and teams for, I don't know, there's a team for everything. And you have to keep this in mind when implementing the solutions that they should use for their use cases. And the foundation is growing. So Blue Surfer, for example, is the latest member that joined earlier, or at the end of the last month. And yeah, so when you're interested in this, there's a talk tomorrow. Some guys from SAP and T-Systems join us, and we'll give a short overview of the NeoNephos Foundation and the idea behind and how to combine this with Alaska, as well as also the SCS project. And the next step we have to do now is, so we have the Gardener, we have the cloud pods to do OpenStack deployment, so this is a solved problem, but now we have to implement a managed multi-cloud service on top of this, so that we can abstract the cloud service providers to build up a multi-cloud managed service provider on top of the cloud service providers, and to measure the quality of them and to resell them, and to have a central contract management and central identity management and so on. And the working title of this is Plexsphere. This is the upcoming platform layer on top of the BTC private cloud that then combines with the existing cloud brokerage service, combined with the hyperscalers and the regional large cloud providers. And then we have a managed service provider like the BTC is, and we can offer on top of this service landscapes that are integrated with the existing customers, and can also offer them a private cloud pod when they have demand for this, and can also deploy then the services inside their own data center. But in the end, we have one middleware layer above all of those small cloud service providers combined like with AWS, and can merge them to one large platform layer. So this is the vision behind the BTC private cloud project we are currently building. And yeah, I think this is it. Probably was too fast, but yeah.